Very good morning to one and all. This is Ven Ahmed, roll number 205018. Today I am going to present on the topic gradient, divergence and curl. So first of all, gradient of a scalar field. A gradient of a scalar function f, where f is the function f, x1, x2, x3 up to xn is denoted by nabla f, or where this delta up, which is upside down, this symbol is known as nabla, denotes the vector differential operator del. The notation grad f is also commonly used for the gradient. The gradient of f is defined as the unique vector field whose dot product with any vector v at each point x is the directional derivative of f along v. That is, nabla fx dot v is equals to dv fx. Now, in three-dimensional Cartesian coordinate system, it is denoted by del f is equals to I del f upon del x plus j del f upon del y plus k del f upon del z, which is also equals to del f upon del xi plus del f upon del vj plus del f upon del z k. Now, next thing is physical interpretation of gradient. Using the language of vector fields, we may restate this as follows. For the given function f, x, y, gravitational force defines a vector field over the corresponding surface z is equals to f, x, y. The initial velocity of an object at a point x, y is given mathematically by nabla f x, y. The gradient also describes the direction of maximum change in other contexts. For example, if we think of f as describing the temperature at a point x, y, then the gradient gives the direction in which the temperature is increasing most rapidly. Now, next thing is curl. In vector calculus, a curl is a vector operator that describes the infinitesimal rotation of a three-dimensional vector field at every point in that field. The curl of that point is represented by a vector. The attributes of this vector, that is length and directions, characterize the rotation of that point. The direction of the curl is the axis of rotation as determined by the right-hand rule, and the magnitude of the curl is the magnitude of that rotation. Now, the definition of the curl says it can be defined as the curl of a vector field f is another vector defined as the following determinant, where the determinant is curl f is equals to vector I, vector j, vector k, then del x, del upon del x, then next is del upon del y, then del upon del z, f1, f2 and f3, and it is equals to del f3 upon del y minus del f2 upon del z, vector I plus del f1 del upon del z minus del f3 upon del x into vector j plus del f2 upon del x minus del f1 upon del y, vector k. It is also defined as nabla into nabla cross f dot n vector is equals to limit a tends to 0 1 upon determinant a surface integration f dot dr. Now, the next thing is divergence. In vector calculus, divergence is a vector operator that measures the magnitude of a vector field source or sink at a given point in terms of a signed scalar. More technically, the divergence represents the volume density of outward flux of a vector field from an infinitesimal volume around a given point. Now, the divergence is if f is equals to pi plus qj plus rk is a vector field on and del p upon del x, del q upon del y and del r upon del z exists. The divergence of f is the function of three variables defined by divergence. F is equals to del p upon del x plus del q upon del y and plus del r upon del z. Now, in terms of gradient operator, that is nabla is equals to del upon del x into I plus del upon del y into j plus del upon del set k. The divergence of f can be written symbolically as the as the product of the two and f. That is divergence f is equals to nabla dot f. Thank you so much.